Hello again. Arising out of the last two videos that I did on PowerSDR, there appears to be some need for a demonstration of setting up TX profiles. As you may recall, if you've watched the setting up PowerSDR video, that I mentioned that I seem to get an unusually high incidence of unsolicited good audio reports. I'm not an audiophile, I don't profess to be, but I do like to sound good, and I do like to be neighbourly to other radio amateurs. In order to show you setting up TX profiles, the logical thing for me was to reset my radio again from scratch, so that I could actually show you setting up a TX profile from cold. But before I do, there are a number of issues which I need to bring to your attention so that you don't fall foul of these problems. The first is that PowerSDR is an application on a computer. It is digital. It is dealing with only digital domain. As amateurs, we're very familiar with analog audio, the analog microphone signals going into the radio, etc. But of course, as soon as it gets to the flex, it's then converted A to D into the digital realm, and from that point on until the necessary baseband is sent back to the flex, everything that happens within PowerSDR is digital domain. And in the digital world, in certainly the world of digital audio, we cannot exceed 0 dB without introducing distortion. 0 dB is the peak, if you like, the maximum that the ADC can sample before introducing distortion. So it's imperative when we're setting up the audio, we do not allow at any point of the TX audio chain to exceed that 0 dB threshold. The purpose of this exercise is to set up a good, strong TX profile that makes the best of our voice but stays within the acceptable range. So the first thing that I'd like to show you, the transmit profile brings with it a number of changes that happen throughout PowerSDR in places that you may not expect. I'll demonstrate this now by bringing up the mixer, and what I'd like you to do is watch. I'll import a couple of the other profiles that Flex have provided here. Let's go with a PR40 with a W2 IHY, yes please, and a PR781 with equalizer and compander. Okay, watch what happens when I select these profiles. Default. Everything is flat on the equalizer. Default DX. Look, suddenly we've gone from a 10 to a 3-band graphic equalizer. But also, look at the other values. FHM1. That profile has changed all of these settings. It has now adjusted the equalizer and enabled it. Let's go to the PR40, keeping an eye on the microphone section here. You see again, the compander moved very slightly, the microphone gain was turned down considerably. On the graphic equalizer, we've gone back to a 3-band, but it's not enabled. The profiles do indeed affect a great many things beyond that which might seem initially obvious. Let's move that there to a useful position. We don't need the second receiver for this. Let's set up a new profile. First of all, we'll give our profile a name. We'll call it SSB Normal, and we'll consider this our rag chew, if you like. just normal everyday talking on the radio. So now we have a profile called SSB normal. The next thing I would like to do, I'm going to set my low to 150 Hz and my high to 2850 Hz. That gives me a transmit bandwidth of 2.7 kHz. I think that's more than adequate. We certainly don't want to go any further than that. At this stage, we are not interested in the downward expander or the noise gate. I want a 10-band graphic equalizer for this exercise, so that's what I'm going to use. Flex, in their infinite wisdom, have provided us with a whole series of metering. This is essential to be able to get the transmit audio correct, to utilize all that have been provided. Yes, of course, we're interested in the output power, but that is at the end when we can tweak the settings. To begin with, we need to set ourselves up a straightforward, well metered and well averaged TX audio chain. And so to begin with, of course, we'll want the microphone because that is the first part of the exercise. Now, before I go any further, one thing that I would like to demonstrate to you, because this is an audio stage, there is inevitably going to be noise associated with it. The microphone will indeed pick up noise. There will be noise generated by the ADC. All of these things are unavoidable. What we do need to do is to make sure that we stay on top of it. This is the setup for adjusting the TX profile. Flex 5000. I have a microphone plugged in to the microphone socket on the front. This goes to my ISK angle poise arm and to my Heil PR40 microphone. For the receive monitor, I'm using my trusty old FT897D. Into that I have plugged in a set of headphones which I will use to monitor my TX audio. So I'm going to put the flex into transmit. Just start the 897. Okay, so the flex is in transmit, and of course, as you can see, there is deflection here. I'm running into a dummy load. The output power level is immaterial at this stage, but there's nothing wrong with leaving it there in the middle. The output power doesn't in any way affect the preceding audio stages. If you look when I'm not speaking, you will see that there is a flat line of noise here. Now, of course, I can increase the microphone gain to increase the audio stage, and I can decrease it. But even with the microphone gain on 0, you can see there is still a component of noise being transmitted. Now look what happens when I take the microphone gain down. Now the noise has all but disappeared, but of course we also have no deflection on our microphone stage here, so this is of no use to us. The point I want to illustrate is that we need to stay in control of the noise and use as much gain as is necessary, but no more, for each stage. The Vox. Because of course the Flex being an SDR, there will be an awful lot of people not using fist microphones with them. You may be inclined not to be pressing the MOX button with the mouse in order to put the radio into transmit. So there will be a contingent who want to use Vox. The Flex 5000, and I don't know whether this applies to the other models, but the Flex 5000 only has an additional preamp in the microphone, the 8-pin microphone connection on the front of the radio. If, like I did to begin with, you connect your microphone to, say, the balanced line in, you'll find that without outboard equipment there is insufficient gain to be able to activate the Vox feature, and of course this will be very, very frustrating. I'll demonstrate here. With the microphone down on low, I enable Vox, but as you can see there is no deflection on the level indicator. If I get really close to the microphone and talk hard into it, still nothing. If I start to increase the gain on the microphone level on the mixer, you'll see that deflection begins to occur. Now if I increase the gain on the microphone even to its absolute maximum, it's having no effect. So this is a point to bear in mind, that if you are or intend to use Vox, then you will need to set your initial level for the microphone using this microphone input level slider. So okay, here we go. Now that I'm beginning to activate the Vox, okay, let's move it down a stage there. Let's go down a little bit more. That seems to be doing a reasonable job. As you can see, there is overshoot and undershoot. It seems to be working just fine. We don't need to concentrate any further on the Vox for the time being. Now we need to start thinking about the gain in the transmit audio stage. So I put the radio into TX. As you can see already, I have this being caused by the noise. But we aren't having any deflection to speak of up here at the microphone level. And so this is where we begin our exercise now. So we'll begin to increase the microphone, and at this point I must put my headphones on so that I can hear the transmitted audio coming through the 897. The microphone is in the working position. Before I do, one thing I omitted to draw your attention to is that there is another audio stage which is in another section, and by default it is enabled, and that is the leveler. And this is another type of compression which reduces the dynamic range of your voice. But if you look, the leveler is actually down here 2 stages further down. So at this point we don't want the leveler to be enabled because it will give us incorrect readings. So we're going to uncheck the leveler and then come back to the transmit section, and we're going to increase the microphone gain, and as you see now there is increasing deflection on the meter and the level indicator is moving up. I'm going to speak into the microphone in my normal everyday QSO voice, and as you can see, by raising my voice quite considerably, it does peak quite close to 0. I can move the slider a bit further on, and as you can see I'm well over the 0 dB point. This is a digital stage, therefore we must adjust it accordingly. And so for each following stage that we go through, we must ensure that we do not exceed the 0 dB point. And as you saw there, with the plosive, you saw the needle move above the 0 dB mark. So we need to decrease the audio, the microphone gain, sorry. So we'll keep trying. Okay, this is Golf 7 Charlie, November Foxtrot, testing audio into a dummy load. Golf 7 Charlie, November Foxtrot, testing audio, plosive, sibilant, plosive. We can increase the audio a little bit more. Golf 7 Charlie, November Foxtrot, testing audio on a Flex 5000 into a dummy load with a Heil PR40 microphone. Now as you can see, the deflection is around -15, peaking to about -5 to -3, and that's by being aggressive. That is more than adequate gain for this stage. We're done with the microphone stage. That's more than adequate. We have good metering, but we're not exceeding the maximum level. The next stage is EQ, Equalization. We can dismiss the mixer, and as I said, I like a 10-band graphic equalizer, so I'm going to enable it, and I'll just demonstrate here now. And if I pull down the bass levels and put up the mid-range and the top range, you can see that the audio becomes extremely toppy, and you get the sibilants becoming way too accentuated. So we'll reset that back to 0, and as you can see now, the audio is actually quite muddy. Another important thing to note here, of course, is that like all the audio stages, the equalization stage must not cause our deflection to exceed 0 dB. Now, if we take the average gain of our sliders to above 0, we will need to compensate on the preamp by reducing the gain. If I demonstrate by bringing up the bass, as you can hear, that's made quite a difference to the voice, and I'll bring up the top end as well also. In fact, I'll bring up the middle, and as you can see now on the meter, on the equalization deflection, I'm going way past the 0 dB mark again, which is completely unacceptable. But if I reduce the gain on the preamp, as you can see, hola, plosive, you can see that it's possible to compensate for the excessive gain. Let's quickly adjust this to the way that we want. We've already set our TX bandwidth filter to a low of 150, therefore any settings under 150 are going to have precious little effect, although of course we go from 125 to 250, so there will be a component that will be affected, but on the 10 band, 63 and 32 will make no difference whatsoever to our audio because they are outside of the skirt of our transmit filter. So, one of the things that can make microphones muddy is around the 1K mark, the mid-range. So I'm going to pull 4K down, increase 2K a little, increase 500 to compensate some voice power for what I've pulled out of 1K. We'll just move that up a touch, and as you can see now, I've got good deflection on the FT897 on the signal meter. The audio coming through is not bad at all, but as you can see when I'm talking, I'm exceeding 0 dB on the deflection up here. So we need to compensate for that. We'll pull the audio down a little, and we'll see how that takes us. This is Golf 7, Charlie, November, Foxtrot, testing audio into a dummy load, Flex 5000 Heil PR40. Golf 7, Charlie. Now, again, I exceeded 0 dB on the aggressive part of my speech. So let's just test this again. Now we're talking normally into the microphone. Our equalization range is between -15 and -5. Golf 7, Charlie, November, Foxtrot. The TX audio is more than adequate. Our maximum filter is at 2850, which means that the 8 and 16K are going to have no effect whatsoever, but at 2850 there is a component above the 2K which can be adjusted somewhat. So we'll keep that fairly high in order to keep the audio relatively sharp. That doesn't sound like a bad audio. It's certainly not muddy. If I take the equalizer back out again, you can see that the audio of my voice becomes quite nondescript. Whereas if I have the equalizer in, it has accentuated some components of my voice and made it appear more dynamic.
If that's possible.
we've now finished with the equalization part of this process. We can move on. The leveler. In order to go back to the leveler settings, we need to look at DSP, the ALC tab. And as you can see there, we unchecked the leveler before we started. This is a type of compression which, if you see, I've just enabled it with 5 dB of compression. My voice suddenly became far more pronounced. Take it off, Golf 7, Charlie, November, Foxtrot. Put it on, Golf 7, Charlie, November, Foxtrot. But, and here is the but, look at the level of my audio. It is going up to and crossing the 0 dB mark. So therefore, we need to consider very carefully the level. But also, you should read the manual and take a look at the settings here for the decay and the hang, which affect the speed in which the leveler acts on the voice. If it's slow, then of course it will be slow to respond. If I bring the decay time down to extremely low level and the hang time to say around 250, then what it allows the leveler to do is to quickly compensate for the differences in my speech. Although the leveler is doing a good job, it is part of the TX audio chain, and therefore it's imperative that, along with the other stages, we do not contribute to overshooting the 0 dB mark. And again, as you saw in the sibilant, overshooting, Golf 7, Charlie, November, Foxtrot, I'm still overshooting. So I'll bring the leveler down to 3 dB, and we'll give that a try. Golf 7, Charlie, November, Foxtrot, Germany 7, Canada, Norway, France. As you can see now, the deflection on the meter is going between -15 roughly to peaking around -3 to 4, which is more than adequate. There is a noticeable improvement in the presence of my voice, but at the same time we're not exceeding the maximum level that we want for this audio stage. So that concludes settings for the leveler. I personally keep these levels fairly low because I like the fast acting. I do tend to like my audio fairly choppy, but these settings will need to be dynamically adjusted to your voice. Now on to the ALC, and here is the proof of the pudding. If we have adjusted each of the preceding stages correctly, then there is absolutely no reason on earth at this point for our ALC to exceed the 0 dB mark. If we've accomplished that, then we have indeed accomplished everything that we need to do in order to have a reasonable audio, and to be sure in the knowledge that we are not going to exceed that point in which the unreasonable levels of distortion will start to be introduced. We'll take now a look at the ALC compression. If we have our levels set correctly, then there should be no ALC compression. If any compression occurs, it's because we're exceeding the 0 dB mark. And if I go close into the microphone, then the limiting is now taking place, compression is taking place, there is deflection. We don't want that. We want our audio stage to be clean and not exceed that 0 dB. I know I keep pressing this point home, but it is so imperative, and it's so frequently missed by newcomers to Flex setting up audio for the first time, because it can be very daunting, let's be honest. I'm thinking that my audio is actually a little bit on the choppy side, so I'm going to go back to the EQ, and I'm going to actually pull down this a little bit just to reduce the choppiness, Okay, this is Golf 7 Charlie November Foxtrot, testing audio. I'm going to try and push this up one notch to compensate for the reduction. Golf 7 Charlie November Foxtrot. Now what we can do is we can go back to ALC and take a look at the levels and make sure that we have got no compression creeping in. Golf 7 Charlie November Foxtrot, testing audio into a dummy load. And as you can see, we've achieved the goal of 0 dB ALC compression, which is what we want. At this point, we have the option of introducing the Flexus compressor, should we so desire. They call it DX. This is DX on setting 0, and I can increase the DX. I can increase it up here quite some way, and as you can hear, my audio has become distorted, it's unpleasant, and you also notice that of course there is a deflection on the ALC as well. But you'll notice, having taken this back down to 0, I can move this up and introduce a reasonable amount of compression and a reasonable amount of aggression into my voice, and yet still not result in ALC deflection. We'll take a look at the ALC here again now, and as you can see, it's pushing the audio up. It's reduced the dynamic range and it's compressed it up so that it's sticking an awful lot between -10 and 0. But we're not actually exceeding that point, which will result in distortion being introduced. So we'll go back to the ALC compression, which is our ultimate measure as to whether or not we have attained our goal of a clean audio stage. Now, conversely, there is the compander. This is with the compander off, and this is with the compander on. And again, we can increase the level from the compander, and this too will introduce a type of compression, but it is a little bit more gentle than the DX compression. ALC compression here, let's go back and take a look at the ALC. And as you can see, the ALC is very much mid-range on the meter, but we're still staying fairly well in control. The popping and crackling you can hear is most likely as a result of my very, very low buffer settings on the audio tab here, 256. And of course, when we go back to normal operations, then that would be changed. It was only brought down to this level so that we could monitor our own voice in headphones without there being a substantial delay. Here we now have the ALC running with the compander at about mid-range. We've got our transmit equalizer on. We've got ourselves a punchy audio. One could say that that is the end of the process, but, and here is the fantastic bit, Flex have included a downward expander. Now you can use this, as I explained in the setting up video, you can use this as either a noise gate, which is exactly that, it is a gate. You set a threshold, and when your speech exceeds the threshold, it lets the speech through. When your speech doesn't exceed that threshold, it lets nothing through. I'll demonstrate. For it to operate as a noise gate, you must set the attenuation to 100%. That is full gating. I'll enable the noise gate. Now, see what's happened here. In between the speech peaks, I haven't stopped transmitting, but it is letting my voice through, but in between, all that noise has gone. You know how noisy an amateur shack can be. You may think that having a noise gate is going to be extremely beneficial. But there is a problem. It can make your speech sound unrealistic. If I set the threshold as an example here at minus 28 dB, I set it to minus 19. As you can see here, my speech isn't making it through. So what we need to do is to determine the lowest level that our speech occurs at and set that as the limit for the threshold. By having it too quiet, of course, you will be able to hear things like fans, computer fans, amplifier fans, etc., all going on in the background. So it's important at this stage to find that balance. It seems to be working relatively well here at minus 55. But this control has been brought out to the front panel of the Flex. As you can see, as I move this slider here, this threshold value adjusts in league with it. It is one in the same value. Ultimately you will have control. This is the good part, because the metering that's been provided on this part will tell us exactly where our shack noise level in the silence occurs. So in between speech, as you can see, the noise gate is actually not being activated at all because the noise is exceeding the activation threshold. I'll use the mouse wheel to adjust this. And there we go. We've just gone past that threshold and the noise gate is working. But Flex went beyond this, and they have introduced a downward expander, which is something you often find used in professional broadcast. And what the downward expander does, it introduces a limited noise gate. Instead of attenuating your background noise completely, often causing the cuts and very, very choppy sounding audio, which can be quite unrealistic, by using the downward expander, you can adjust the attenuation so that it only partly attenuates the background noise. Noise gate 100%. As you can see already, I've adjusted it to 91, and the attenuation is 91%. If you look at the level of the noise now in the background, you can see it's hovering around minus 95 on this scale. If I adjust, I can increase the attenuation or conversely, I can adjust the attenuation to a low level. There's zero attenuation, 20% roughly. With the monitor radio set up the way that it is at the moment with attenuation, you can't really appreciate the benefit. But what I can do is I can now make a change to the sensitivity of the 897 to demonstrate more graphically the effects of the downward expander in operation. So if I disable that, okay, so now this represents being a much stronger signal. Somebody that's coming in on a S9 Plus, etc., much stronger. You can hear the shack noise. There's stuff going on. There's my PC fan. There's the fan in the 897. There's a little bit of noise from outside. All of this is coming through with my audio. You're listening to my transmitted audio coming through the 897 at this point in time. The audio may be good quality, but there is an awful lot of noise there. And isn't it really irritating the way that you can hear the noise coming through when operators have their compression set far too aggressively? Here we go as another demonstration. If I give my signal some aggressive compression. Now, as you can hear, I've got a quite strong compression running. We'll just check the ALC compression to make sure that I'm not exceeding. One could describe this as a DX signal. You can hear multiple fans in the background. What I'm now going to do is I'm going to implement the downward expander. At the level I've got it set here now, it may not make a tremendous difference. It's at roughly the kind of level where the difference will start to be noticeable. So I will stop speaking and enable the downward expander. So with the attenuation set at 69, the downward expander is now attenuating my background noise between speech peaks to 69% of maximum. My audio sounds louder and more well defined as a result of the downward expander. If I have the downward expander turned off again, you can hear the fans in the background, and you can hear a flea fart. By adjusting the downward expander dynamically according to your settings here, so that you can achieve a very, very good quality. I've adjusted that just a few more percent. Listen to my background noise now. It starts to become quite noticeable, does it not? Let's increase it to 80. If I make some adjustments in silence, watch the noise level deflection here on the transmitted audio signal. Zero attenuation represents the downward expander turned off. I keep mine somewhere between 80 and 90% depending upon my settings. So, this is my audio, still with no ALC compression. It's aggressive, it's DX. It's fairly full range, but it's also very noisy. Now the downward expander is in. You can hear my voice. My voice is pronounced, well defined, still full range. Maybe a little bit too much sibilancy at the moment, perhaps, but nonetheless, where has the shack noise gone? It has disappeared. Now, just to finish things off, we'll take a look to see quite where we're to with our output power. So this is Golf 7 Charlie November Foxtrot. Golf 7 Charlie November Foxtrot testing audio into a dummy load. George 7 Charlie November Foxtrot. Looking for peak audio power. Adjust the DX expander a little bit more. because of the breath noises. George 7 Charlie November Foxtrot testing audio into a dummy load, recording a video for YouTube. This is Golf 7 Charlie November Foxtrot. Okay, so we might want to try and improve our PEP. So we'll go for Golf 7 Charlie November Foxtrot. Okay, Golf 7 Charlie November Foxtrot. Testing audio into a dummy load. Now that I've put the X on, Golf 7 Charlie November Foxtrot. Testing audio only into a dummy load. Germany 7 Canada Norway France. Golf 7 Charlie November Foxtrot. Golf 7 Charlie November Foxtrot. Testing audio only into a dummy load. George 7 Charlie November Foxtrot. So as you can see, we're not reaching 100% on our meter here. And what we can do is go back and take another look at the leveler. We'll take our metering back to ALC. Actually, we'll leave it at ALC compression. We'll increase our max gain by 1 point. Okay, this is Golf 7 Charlie November Foxtrot. Germany 7 Canada Norway France. You see that minor movement just there on the aggressive part of the audio. Golf 7 Charlie November Foxtrot. Testing audio. That's not bad. There's still not too much movement. Forward power. Golf 7 Charlie November Foxtrot. Germany 7, Canada, Norway, France. Hola, 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 hola. So we're getting very close to 100 watts peak envelope. I think what we can do, though, is take another look at the attenuation here. Okay, this is Golf 7 Charlie November Foxtrot. Germany 7 Canada Norway France. Testing audio into a dummy load for a YouTube video. Golf 7 Charlie November Foxtrot. Germany 7, Canada, Norway, France. Golf 7, Charlie, Charlie, Charlie. It's worth pointing out that fixation with 100 watts peak envelope power is much less effective than concentrating on our average speech power, which of course is the purpose of speech processing. Okay, just as a final case in point, what I can do is, you've now been listening to me for some while with a downward expander operating. It would be useful now to be reminded what my audio sounds like without the downward expander in operation. So, as you can see, what more can I say? Okay, so there we have it. The downward expander is eminently useful. So here we have the final test. If you take a look at the average speech power now, you will see that in fact I'm very rarely dipping below 50 watts forward power. If we take a look at the ALC, as you can see, it's dancing around a great deal, but we don't appear to be exceeding 0 dB. We take a look at the compression level. I've introduced the decimal point here as well, just to make sure that we don't creep over. And as you can see, we seem to be well in control of it. So, just barely peaking there, as you saw momentarily. Audio is punchy. ALC is under control. But, hola, that's okay. But that about? That awful noise in the background. Oh my word. What a change, eh? And that is the reason why I repeatedly get good audio reports. Although I have this set up more aggressively than I normally use as a demonstration, I do believe that this amply shows how capable the Flex is in controlling the environment for your audio. So thank you for your time. I've been G7CNF, and I hope that you have the opportunity to enjoy your Flex radios. 7 3s.